In this next section, we're going to go through complex fractions. And so we're going to talk about three main things. First, what does a complex fraction look like? Second, how can I possibly simplify complex fractions? And we're going to start with just numbers as opposed to something involving variables. And then we'll bump it up and see, okay, what do I do then when I have variables in the mix? So when we hear this word complex, it means it's something that's more complicated. So we have a fraction that already has a numerator and a denominator. A complex fraction contains fractions within fractions. So formally, it's a fraction that contains another fraction in both the numerator and denominator. So just to give you some examples, so we can have our fraction, we could have 3/4 in the numerator, and we could have 7/9 in the denominator. That's a complex fraction. We also can have variables again. So I can have x over x plus 2 in the numerator, so fraction within the numerator, and then another fraction in the denominator. And again, plenty of options for what these look like. These are just two, but you have fractions within fractions. So we really have two main methods to simplify these. Really, you can kind of do either one, whatever is going to click best for you. I'm going to go ahead and do our first case where we have just a regular complex fraction involving numbers both ways. But I personally tend to gravitate towards one of the other methods than the other. But if you like the other version, again, pick what works best for you. So the first option is we go ahead and we simplify the numerator and denominator separately. Then once you've gone ahead and condensed it to a single fraction in the top, a single fraction in the bottom, remember fraction is just indicating division. So I changed this division to multiplication and then simplify. The second option is we can go ahead and wipe the complexity by multiplying the top and the bottom by the least common denominator. So we're basically wiping those fractions and fractions and getting a single fraction in return. Then once you do that, we go ahead and simplify. And so my personal preference is this one because I think the second one can get a little bit messy. But again, either one works for you. When we go ahead and talk about dealing with variables, absolutely nothing is going to change. So let's start with this first example. We have 4/3 minus 2 in the first numerator and 1 minus 3/8 in the denominator. So the very first thing I want to do is I want to go ahead and clean up to get a single fraction here, a single fraction here. So what I need in this first fraction is I've got 4/3 and we're subtracting 2. To get it with a common denominator, we would have to multiply it by 3/3. In the bottom, we have 1 minus 3/8. To make it a single fraction, this piece we'd have to multiply by 8/8. And so what this gives us is 4/3 minus 6/3 in the numerator, and then 8/8 minus 3/8 in the denominator. And now, because the numerator has the same fractions, we go ahead and we subtract across. So we have 4 minus 6, which gives us negative 2/3 in the numerator. And then 8 minus 3 leaves us with 5/8 in the denominator. And now, because we have a single fraction divided by a single fraction, all you can think of this as is this is the numerator, negative 2/3, divided by this denominator. So all we need to do is go ahead and we need to change this to multiplication. So we have negative 2/3 times 8/3 or 8/5. Be helpful if I flip that second one correctly. And now from here, we go ahead and just multiply across because I don't have anything that simplifies. 2/5 doesn't simplify. 3/8 doesn't simplify. This multiplies across to negative 16/15. And now you can see there's no common factors in the top and bottom. Okay? So this is one way we can simplify a complex fraction. Let's try the other way for the second problem. So here we have 3/4 and 5/12. What I want to do is I want to wipe these fractions. So I want to figure out what number can I multiply the top and bottom by that will clear these out. So the least common denominator between 4 and 12 is 12. 12 is divisible by 4, and it's divisible by 12. So I'm going to take this expression, I'm going to multiply it by 12 in the numerator and 12 in the denominator. So this way it will wipe these fractions. So we really have 3/4 times 12 in the top, and then 5/12 times 12. So in the bottom, those 12s cancel each other out. In the top, 12 over 4 simplifies to 3. So we're left with 3 times 3 in the numerator, and then really 5 in the denominator. So this simplifies to 9 over 5. Okay. So either way, you can do which method works best for you. The second method isn't bad when you're just dealing with numbers, but the second you start throwing expressions in, then it gets a little bit more complicated. Okay. So now we're going to go with what do we do when there's variables? And honestly, again, nothing is going to change. It's a little more complicated for sure, but it's still the same process. So for this first one, I've got, again, fraction within a fraction. So I personally like the fact of flipping this to a division problem because we are used to that. If you wanted to multiply by the LCD, in this case, you'd have to take the top and multiply it by t plus 4 and t. And the bottom, you'd have to multiply by t plus 4 and t. And this way it would make the t's cancel and the t plus 4's cancel. And then from here, we would simplify. We'd have 24 and a t in the numerator, and we'd have a 6 and a t plus 4 in the denominator. Okay. And then we go ahead and simplify it some more. So we've got 24 over 6, which leaves us with 4. And so that leaves us with 4t over t plus 4. Okay. So that would be using this second method. But again, I'm personally a fan of the first one. So we're taking 24 over t plus 4, and we are dividing it by 6 over t. So we change this just to those types of problems we were doing in the first section. We flip the fraction and times it by t over 6. And then from here, 24 over 6 simplifies to 4, and we end with the same expression of 4t over t plus 4. I think the benefit of this one is then you don't need to find what that least common denominator is, so it saves you a bit of a step. And I think this tends to get a bit messy. But again, personal preference, whichever method you want to use, they're both going to get you to the same answer. So let's try another one. And I'm just at this point going to turn these into division problems once we have a fraction divided by a fraction. So I'm taking the first fraction of 5 over y plus 2, and we are dividing it by -3 over y squared minus 4. So I'm going to flip this and change it to multiplication, and then simplify. Really, at this point, you can just jump from this step to here, so go ahead and multiply by the reciprocal of the denominator. But now for this one, we have y squared minus 4. We can factor that a bit. So that's 5 over y plus 2. The -3 in the bottom does not change. And then this factors really nicely as y plus 2, y minus 2. So these factors of y plus 2 actually cancel each other out. And we're left with 5 times y minus 2 over negative 3. And then this you could leave exactly like this. It should be fine accepting it into the software. If it does give you issues, then just let me know. Let's try an even more complicated one where we run into an issue where I have really not a fraction in the numerator. That's okay. But I don't have a single fraction in the denominator. So I can't turn this into multiplication yet because I can't take a reciprocal of this expression. So what we need to do is we need to actually condense what's happening down here. So I need to multiply this one by x over x and this one by y over y to get the same denominator in both pieces. So we still have x plus y in the numerator. In the first fraction, we have x over xy. Then we have y over xy. And so now we can actually condense this bottom fraction as x plus y over xy. And now I'm taking this piece and I'm dividing it by this fraction. So again, going to add some extra steps. Going to put some parentheses because I'm taking this top and I'm dividing by this fraction, which really is this x plus y times xy over x plus y. And so we really have the same factor for both of these. It just leaves us with xy in the numerator. Okay. The other way you can think of it back up here is if you want this to be a fraction, it's like x plus y over 1. So you have x plus y over 1. And then you don't need to write these parentheses, but still that x plus y cancels, and it leaves you with xy over 1, which is just xy. Okay. So I got one more of these, and thankfully this is already a fraction divided by a fraction. So we go ahead and change this division problem and take our numerator and times it by the reciprocal of the denominator. So we times it by 6y squared over 2x minus y. So now we want to see, do we have stuff that cancels? And again, jump into whatever you see being best first. So if you want to start simplifying the y squared and the y, go ahead. I personally want to kind of clean up these things because I think there's probably a common factor. So in this 20x minus 10y, we can take a 10 out of both of those. And that leaves us with 2x minus y, which is great because we have 2x minus y in the bottom. So those factors cancel each other out. And now I'm left with 10 times 6y squared over 12y. Okay. And then from here, simplify it as you'd like. So really, I think you could do the 6 divided by 12 leaves you with the 2 in the bottom, but then you have a 10 over 2. This is a case that maybe multiplying these numbers will be a little bit simpler. So we have 60y squared over 12y. And then 60 divided by 12 is 5. Y squared over y cancels and leaves us with y to the first. So after starting with such a messy problem, this thing just boils down to 5y.